Lesson 8.7.10, Solar System. Definition of scientific notation. In this lesson, we'll tell whether a number is written in scientific notation, and we'll rewrite large and small numbers using scientific notation. All right, we're on page 144 in your workbooks, and we have those two learning goals: to tell whether a number is written in scientific notation, is written in scientific notation. And also, we're going to be rewriting some large numbers and some small numbers using scientific notation. Okay, I'm using the word scientific, or the words scientific notation, an awful lot. So let's talk about what I'm referring to. In science, scientists often deal with really large numbers, like the distance to planets or the distance to stars. Those are huge numbers. Or really small numbers, like you see if you're working with cells or bacteria and describing how big things are. Those are very small numbers. So they need some way to write it without all those extra zeros. So to define what scientific notation is, it's just a way to write large and small numbers. But it's pretty specific what the number has to look like. There's two parts to the number, and we'll show some examples in just a moment. The first part is a number between 1 and 10. Not including 10, multiplied by a power of 10. Oops. So let's look at some examples. In the activity that we worked with yesterday, you actually worked with some numbers that were in scientific notation. So let's say we have a number like 2 times 10 to the 8th power. So that's what we're talking about. We have a number between 1 and 10 multiplied by a power of 10. Now, that's a pretty straightforward number, but it doesn't have to be just a whole number. Maybe I have something like 5.23. So that's a number between 1 and 10. It's got a decimal part to it, but it's a number between 1 and 10. And let's say we have 10 to the negative 4th power. Now remember, a negative exponent doesn't make this whole number negative. It just makes it really, really small. It makes it a fraction. So just to be clear on this first part, that's a number between 1 and 10. Well, I didn't think this spacing out very well. And the second part is a power of 10. That's what makes it scientific notation. Now I'm going to write some non-examples over here just so that we're clear on why some numbers don't count as being written in scientific notation. Let's do 48,200. That's a really big number, but it's not written as two things being multiplied to each other where one of them's a power of 10. There's no power of 10 here. Nor is there a number between 1 and 10. What about, let's do 34 times 10 to the negative 6 power. Well, it looks a little better. I've got these two numbers being multiplied together. This one's a power of 10, but I should do this in red. This one's not between 1 and 10. So that's wah, wah, both of these. Neither one of these is in scientific notation. So we should be able to recognize whether numbers are written in scientific notation based on whether they follow this definition of what it should look like. A number between 1 and 10 multiplied by a power of 10. Well, our second target is to write some numbers using scientific notation. So we've got a bunch of numbers here, and we're going to write them using scientific notation. And somewhere here, I have a little decimal point that I'm going to use. Pretty proud of this little decimal point that I'm going to use so that we can talk about moving that decimal point until we have a number that's between 1 and 10. So right now, I have 540,000. My decimal point's right at the end of that number. If I move it one spot, I still don't have a number between 1 and 10. I've just changed it to 54,000. And if I move it here, I've just changed it to 5,400 or 540. So I need to keep moving this decimal point until I have a number that's between 1 and 10. And here it is, 5.4. So that's going to be my number between 1 and 10. Let me just write that down. And every time I moved that decimal, I was changing that number by a factor of 10. So let's count how many times I did that. 1, 2, 3, 4, 5 factors of 10 is what I changed from the original number. And I've essentially made this number smaller by changing it to 5.4. So I need to make my power of 10 bigger than it was, which was nothing. So that's going to be 10 to the 5th power. Every time I moved that decimal, that was a factor of 10. Let's take a look at this next one. Right now, the decimal is right here. I have 3 thousandths, or 0.003. First thing I'm going to do is move my little decimal until I have a number between 1 and 10. Not yet. Not yet. 3. 3 is a number between 1 and 10 if I put the decimal right here. Now, I want to note that this was a small number, and I made that number a lot bigger. So let's look at what we're going to do. I moved that decimal 1 spot, 2 spot, 3 factors of 10. But if I make this number bigger, then I have to make this exponent smaller. I just want to be clear. Right now, if I had to put a power of 10 on these, it would be 0 that I'm starting out with. Because 10 to the 0th power is 1. It wouldn't change the value of this. All right, let's do this one. Oh, wait a minute. Let's look at this. The decimal right here is between the 6 and the 8, so that's 6.8. That's a number between 1 and 10. It's multiplied by a power of 10. I think this one's already done. Just going to write it exactly the same way. Perfect. All right, these last two get a little bit tricky, but we talked about this a little bit in a previous lesson. How every time we move the decimal, we're essentially changing where some power of 10 is. If I make this number smaller by a factor of 10, I'm going to make this number larger by a factor of 10. Okay. So let's see how many spots I have to move this before I have a number between 1 and 10. So just had to move it once. I changed it from 12 to 1.2, or 1 2/10. If I make that number smaller, I have to adjust the factors of 10 over here. I have to make this exponent larger. I just moved that decimal one time, so I'm going to make this exponent 1 digit larger, or 1 unit larger. -1 is larger than -2. All right, let's do it down here to finish up. Right now I have 97. That's not a number between 1 and 10, so I have to move this decimal until I have a number that's between 1 and 10. I'm going to move it one, so there it is, 9.7. So I made this number smaller when I changed it from 97 to 9.7. So some factor of 10 gets scooched over to here. I make that exponent larger. Change it from 5 to 6. So all these numbers are in scientific notation. What's important to pay attention to when writing a number in scientific notation? I'm actually going to write it up here. I need a number between 1 and 10. Multiplied by a power of 10. And that's scientific notation. All right. You'll be able to use all of those properties of exponents as you do calculations with these, but that is the form that you'll be using if you are a scientist. Enjoy your homework.